Hello everybody, welcome back to lesson 2 of the Guitar Gaze learning course. My name is Eric Wright, creator of Guitar Gaze and author of a numerical and visuospatial method for learning guitar. In the first lesson we talked about standard tuning, why standard tuning over other types of tuning, and then we introduced isomorphic tuning or all-fourths tuning. And we're going to pick up from there. This lesson we're going to go through a brief overview of lesson number 1, but lesson 2 here, the numerical introduction today, is truly the core of my approach to guitar and the core of the Guitar Gaze platform and the executive summary of this entire learning course. So if I had to write an executive summary for all 10 to 20 lessons that are going to be in this learning course, it would be lesson number 2, the numerical introduction. So today we're going to go over, as I mentioned, the lesson 1 review. We're going to assign numbers to the notes. So we're going to make our second change, which is the numerical note assignments added on top of the isomorphic note layout that we introduced in lesson 1. We're going to add color onto that. We're going to look at the 2-dimensional note order on the guitar. So that is the order of notes going up the strings and the order of notes going up within an individual fret. We're going to look at the 13 by 13 isomorphic structure of the guitar, which is this beautiful image you see on the right here that will make sense at the end of the lesson, will actually be a way for you to seamlessly navigate the fretboard of the guitar. And we're going to go over all of the symmetries of the guitar, including what you see in the image to the right there. So let's get into it. Quick overview. Standard EAD GBE tuning on the guitar. Here is your fretboard from the 0th fret to the 12th fret in EAD GBE tuning. This is the traditional alphabetical note assignment layout. You can see here you've got your 3rd fret marker, 5th, 7th, 9th, and then 12th. So this is standard tuning layout, and the question is, should this be the starting approach for learning guitar? If you look at the intervals from string to string in standard tuning, as we went over in lesson number 1, all of them are the same. All of them are equivalent to 5 frets, except for the interval between the G and the B string. And this is unlike other string instruments. For example, if you look at violin or cello or bass, those instruments are more often than not tuned isomorphically, which just means that the interval between all the strings is the same. For violin, it's perfect fifths. For bass, it's perfect fourths. And for guitar, purely for convenience of finger placement when playing larger bar chords and for adding color more easily to certain chords, we create this inconsistency here by tuning the top 2 strings to B and E instead of C and F, and that's standard tuning. But if we go back to isomorphic tuning by adjusting the top 2 strings from B and E to C and F, a very slight adjustment, what that does is it makes the guitar isomorphic, or it makes sure that the interval between all of the strings is equivalent to 5 half steps or 5 frets or 5 semitones, whatever you want to call it. So you see the A string is equivalent to the 1, 2, 3, 4, 5 fifths fret of the E string. The D string is equivalent to the 1, 2, 3, 4, 5th fret of the A string, and so on, all the way up your guitar. And what this even string interval or consistent string interval across the guitar does is it creates uniformity that is a massive shortcut for learning scales and understanding the guitar, understanding how to form chords, understanding how to improvise. We're going to get into all that today, at least briefly touch on all that today. So the next change that we're making, and what this lesson is about, to unveil more of the symmetries and natural geometric patterns that are built into the guitar. We can't use traditional alphabetical note assignments. We got to think of things numerically. So we're going to introduce numbers, starting with, you can pick any root note. For this example, we're going to pick E. as the root note, and that'll be the root note for the next several slides. So E is our root note, and it's 0. We're assigning that the number value is 0. So the low E string open is 0, and at the 12th fret on the low E string, you've got 0. Now we're going to assign numbers to the rest of the notes, and that is going to be based on that note's location relative to the root note within that octave. So anything that is within 6 frets above the root note is going to have a positive value, and anything that is within 6 frets below the root note is going to have a negative value. So going from the root note, you've got your 1st fret, 2nd fret, 3rd, 4th, 5th. These are all intervals. So your interval is expressed in half steps. Sometimes you'll see interval classes expressed as their absolute value, where you'd have, for example, the 5th fret above and the 5th fret below would just be interval class 5. We are using positive and negative values here, and you'll see that you've got plus 5, minus 5, plus 4, minus 4, plus 3, minus 3. So, you know, it's pretty straightforward. And then the center point in between the root note in 2 different octaves is plus or minus 6, because it's equidistant between both root notes. And that's called the tritone, but I just think of it as the midpoint in between root notes. And it can't be declared positive or negative. It's the middle point. So I just say plus or minus 6. So this is the number assignment that we're going to use. Remember, E is 0, that's the root note. 1, 2, 3, 4, 5, or minus 1, 2, 3, 4, 5, and plus or minus 6. Now we're going to assign that across the fretboard. So the entire fretboard has the same number assignment with E as the root note. And again, this is in EADG-CF tuning, not EADG-BE tuning. So we've got our isomorphic tuning. We've got our numerical assignments. You can see the distribution of notes across the fretboard is very consistent. No matter where you have one number, the numbers around it are the same at every location on the fretboard. So for example, I'll just pick 4. You got minus 3 above it and 5 to the right of it. So let's pick a different 4. You have minus 3 above it and 5 to the right of it. Everything repeats itself, and there's these recurring patterns. Now we add color to it to make that a little more clear. So as I mentioned earlier, sometimes you'll have interval classes that are just based on the absolute value of the interval rather than accounting for positive and negative. In this instance, we assign colors that way. So because, for example, plus 3 and minus 3 are both the same distance from the root note, they are assigned the same color. So these color assignments are based on distance from the root note. And the further you are from the root note, the more dark blue you are, the closer you are to the root note, the closer you are to white. And then in between it transitions into orange. So that's the color assignment. Orange and blue are high contrast colors, so this makes it easy to differentiate from note to note. And with using the absolute value of the interval class as the color coding system, it also makes it easy to see where you have equivalent distances in terms of absolute value of interval. So now we're going to expand our gaze. So this is where we were. Now we're going to pretend like we're adding another bunch of strings. So 1, 2, 3, 4, 5, 6, 7 more strings on top of the 6 strings of the guitar. So we're going from 6 strings on the guitar to 13 strings. So we're looking at, in total, if you count the 0th fret here, we're looking at 13 fret distance on the x-axis and a 13 string distance on the y-axis, if you were to think of it that way. So we're expanding our gaze so that we can more easily see this recurring pattern. If you actually just zoom out or step back from this, or you were to repeat this over and over and zoom out really far, it would actually just look kind of like a woven basket pattern. It's a very repetitive, redundant pattern, which makes it easy to learn things on the guitar when you're thinking of things this way. So just to clean things up a little bit, we're going to take away the fret markers and the string names on the left, so we're just looking at our 13 by 13 isomorphic note structure here. Now let's highlight the central row and the central column. So the central column and the central row in this image. This is the center, or the two dimensions of the guitar. So you've got, just as you have a repeating pattern in the horizontal going up a string, you know, you've got 0, 1, 2, 3, so on. You have a repeating pattern of 12 notes in the vertical, staying within a fret and going up the strings within a fret. No matter where you are on the guitar, for example, if you start it, let's say A is 0. You go up a string, you're at 5. You go up another string, you're at -2. No matter where you do that on the guitar, so here would be another A, that's 0, that's 5, that's -2. Same exact repeating vertical pattern of notes, just like there's a repeating order of notes on each string. So if we look exclusively at those two axes of notes, there is a particular vertical order that is based on the string intervals. So on the bottom here, I've got the order of notes as they go up a string. So 0, 1, 2, 3, 4, 5, plus or minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, so on. And you can use that as a guide for what I'm about to walk you through here. So if we start at 0, as I just said, you go up a string, you're at 5, which is your interval. So this line connects you to where you are in the horizontal. That's your vertical to horizontal relationship. Also, feel free to pause this video at any point if something doesn't stick. It'll be worth it in the end, I promise. Take your time going through this. You don't want to rush. So now, if we go from 5 and we add 5 more steps, that's equivalent to the string interval. So we're going up a string. You go from 5 down here, 5 more steps, 1, 2, 3, 4, 5, that gets you to -2. So from 5, 1, 2, 3, 4, 5, that gets you to -2, which is the next spot. 1, 2, 3, 4, 5 gets you to 3. 1, 2, 3, 4, 5 gets you to 4, and so on. Same applies to below the root note. This shows you the vertical to horizontal relationships of the two-dimensional system of the guitar. This is the core of the guitar, and there are symmetries in this core. So notice the symmetries of this line. If you were to draw a diagonal line going from bottom right to top left, you can see that these lines would be symmetrical about that axis. So we're going back to our 13 by 13 isomorphic note layout here with those same lines over it. You can see your central column and your central row. And we're going to add some lines to look at these symmetries. So these lines all extend from your central root note out to all of the other adjacent root notes. So, for example, from the central root note here, this is one of the first adjacent root notes right here. This other one is up 2 strings and up 2 frets. Another one would be back 3 frets and up 3 strings. So that's a 4x4 box. This is a 3x3 box. You've got 2x6, 6x2. These are all the adjacent root notes relative to that central root note. So why is this important? So these lines intersect rectangular areas of notes that all have a root note in one corner and a root note in the opposite corner. All of these lines, I'm going to say it again, all of these lines represent, or they cross through rectangles or squares that have a root note in one corner and root note in its opposite corner. So within each of these rectangular shapes are further symmetries. And it's pretty straightforward when you think about string intervals and you look at the numbers, but it's a lot easier to just represent it this way and just use this as a rule of thumb for now. So every rectangular structure on the guitar with root notes in opposing corners is fully symmetrical around its central point. Notes within that structure are reflected across the central point to their opposite interval value. Feel free to pause it, read through that again, understand what that is saying, and we're going to show examples of what that is saying. So let's start with the first rectangle or first square that I mentioned, the 3x3 structure. Anywhere on the guitar you have a root note, as I mentioned earlier, if we're going from A. If you go up 2 strings and up 2 frets, that is also the same note. That is A, just of the next octave, and so on. So that's the shape that we're talking about here. You've got the root note in the bottom left corner, and then up 2 strings, up 2 frets, you've got the root note in the top right corner. Now, remember our color assignments here. The color assignments are the same for notes with the same absolute interval from the root note. So you've got this line connecting these 2 notes of the same color, this line connecting these 2 notes of the same color, and this line connecting these 2 notes of the same color. And when you overlay the numbers with it, you see that, for example, you've got -2 is reflected across the central point to +2. -1 is reflected across the central point to +1. And 5 is reflected across the central point to -5. So this 3x3 structure, everywhere that it appears on the fretboard, which is in many places, is symmetrical about its center. And this is a very powerful way to become immediately aware of the interval location of any note in this structure. So without thinking too hard, you can pick this 3x3 box with a root note in the bottom left and top right, and you know that you've got -1 here and -1 here. It's reflected about the central point. -2 here, +2 here, reflected about the central point. 5, -5. So when you think of things this way, you're not just memorizing a note name or an alphabetical note assignment. What you're conceptualizing when you assign these notes and you think about these symmetries is you're becoming aware of the location relative to the root note for every individual note in this structure. Might seem a little complex at first, but if you just spend time staring at this, thinking about it, and practicing, and for example, going over to the Guitar Gaze tool here and pressing listen for this 3x3 structure, for example, I'll start with, let's do 7th fret. So B as the root note. It's listening to what I'm playing. I'm going to go up 2, 5, -5, -2, 0. That is the pentatonic neutral scale, but just being able to see what you're playing on the fretboard and compare it to this concept of this symmetrical structure, that's going to drill that into your head a lot more, and it's going to improve your understanding of note intervals in that region of the guitar, all relative to the root note. And this will be applicable for scales in the future, for chords in the future, and for navigating the fretboard. We'll touch on that momentarily, but first we're going to go through some more symmetries. Next powerful shape, or powerful symmetrical structure on the guitar, is your 4x4 symmetry. So again, anywhere you have a root note on the guitar, I'll start from B again, I guess. If that's my root note, if I go back 3 frets and up 3 strings, that is also the root note. So the same exact logic that applied to the last 3x3 structure applies to this 4x4 structure. So this is a 4x4 symmetrical structure where every note that is contained within it is reflected across the central point to its opposite interval value. When we add the numbers in, you can see. I'll stick in the same location where I've got B as my root note and then B of the next octave, 3 back and 3 up in the other corner. And if we were to do the Dorian mode, for example, which is -3, -2, 0, +2, +3, 5, and -5, that's a perfectly symmetrical scale. That's why I picked it. So just to clarify, the Dorian mode is 0, 2, 3, 5, and it also includes the opposite values of that, -2, -3, -5. So sticking within this box here, I can play -3, -2, 0, 2, 3, 5, -5, -3, -2, 0, 2, 3. So basically, this box of 4 notes, this box of 4 notes, and the 0s and the 5s. You can play those, you're in the Dorian mode. It's just one example, but everything is symmetrical about the central point. 1 reflects to -1, 2 reflects to -2, and so on. So what this would look like, if we go back over to the Guitar Gaze platform and press listen, using the same root note, starting at 0, going up to the other corner, 3 frets back and 3 frets up. Now I'm just going to mess around in that Dorian mode, and you can see what it looks like in this 4x4 box here. So that would be another way to practice around with the symmetries in that 4x4 symmetrical structure. The reason I chose the 3x3 and the 4x4 symmetrical structures to start with are because if you combine them, they overlap with each other and fuse together the interval structures of the guitar so that you can navigate the entire fretboard of the guitar seamlessly. No matter where I am, remember, I know that if I'm starting on a root note, I can go up 2 and up 2. I can go back 3 and up 3. Anywhere I am on the guitar. So I could go up 2 again from here and up 2. So that's our, to be clear, that's our 3x3 shape. If you're going up 2 strings and up 2 frets, you're covering an area of 3x3 notes. So anywhere you are on the guitar, you can account for these 2 symmetrical structures and have a great understanding of the symmetries within each of those structures and what the intervals of all of the notes in those structures are. This is an amazing shortcut for learning scales, understanding scale relationships, understanding how chords fall within scales or outside of scales, you know, if chords are diatonic or non-diatonic. And there's other symmetries of the guitar. So like I said, anywhere you've got a root note in one corner and a root note in the other, everything is symmetrical in that box. So you've got your 6x2 symmetry, you got 2x6, 5x5, 7x7, 13x13. You can combine them. So we showed the 3x3 with 4x4. If you add 5x5 symmetry on top of that, those are the beautiful patterns you get. If you add 7 by 7 on top of that and 13 by 13 on top of that. That's not practical. Nobody can think about that many different points at once. If you did, you'd probably understand how the universe was created. But the point is, if we go back to this structure, fusing the 3 by 3 and 4 by 4 symmetries using isomorphic tuning on the guitar and positive and negative interval class notation, that is going to set you up for fast tracking scale memorization by an order of magnitude. And that is the end goal here, as I mentioned in the last lesson, is to expedite the learning process for myself and for you. So what? What does this look like applied to the guitar? Well, this is a translatable numerical framework that you can work on and build and get in place as your foundation that will fast track everything, and it will deepen your understanding of interval relationships in scales, chords, and improvisation, and it makes improvisation immediately within reach for you if you take the time to stare at the fretboard as you've got available on guitargaze.com. Think about these structures, your 4x4 and your 2x2, and think about the intervals within those structures and just spend time messing around with it. You can, if you wanted to do chord overlays, like put a major chord overlay in there, you could emphasize those. If you wanted to, instead of showing all of the notes, the chromatic layout, you wanted to start with your major, you can do that, and you can still conceptualize that 4x4 and that 3x3 structure, but with the view of the major scale, or as we went through a moment ago, the Dorian scale. Let me get the major chord overlay off of there. And you can do custom color layouts if you want. This is just using the same color layout as the presentation we've gone through today. I do like that color layout, but it's a custom one that I made and saved here. So you can, I did a different layout here that I saved. I like that one too. But you can just click one of the preloaded ones and click either standard or isomorphic tuning. I would recommend going to isomorphic tuning since that's what this lesson's based on, and practicing around with that, toggling different root notes and toggling different scales if you want to do the pentatonic major scale, and just thinking about all of those different things within those symmetrical structures on the guitar and how you can accelerate your learning process in this manner. So that is the so what, and up next in lesson 3, we're going to get deeper into scales, talk about scale relationships. We're going to look at the interval classes that define different scales. We're going to look at the similarities between scales. We're going to, again, spend more time on the pentatonic neutral and Dorian mode. And then we're going to look at some more visual tools for visualizing the scales. So that's it for today. Again, my name's Eric Wright, creator of Guitar Gaze and author of a numerical and visuospatial method for learning guitar. I'm looking forward to seeing you in the next lesson. Cheers.